Good afternoon, and congratulations on your 30th anniversary. Very happy to be part of this, and as we clear that, so we hopefully don't have a tripping hazard, if you could bring up the first slide, please. And I think it's appropriate, I'm following the sessions we had earlier, talking about the grid, talking about machine intelligence, and really about bringing those together. What I'd like to talk about is energy. It illuminates our night sky, it warms our homes, and it powers our economy. And thank you. In the United States, we use a tremendous amount of energy. In fact, about 97 quads of energy each and every year. And at the Department of Energy's national laboratories, we're working hard in partnership with academia and industry to make sure we continue to develop the technologies that will ensure that we have the clean, affordable, and reliable energy that we'll need not only today, but into the future. But another part of what we're doing is looking how we can make greater use and better efficient use of the energy we already produce. And that's important because when we look at that 97 quads, we waste about 2/3 of it in terms of waste heat and other inefficiencies. Let's put that in perspective. What would this wasted energy do for us? Well, it would actually power the rest of our hemisphere for an entire year. Alternatively, it would power the entire Middle East and Africa. So that's a lot of energy that we're wasting. And if we can find better ways to be efficient with our use of energy, we can save that energy, save money, and reduce capital outlays for new power plants. So I wanted to talk a little bit about what we're doing at Pacific Northwest National Laboratory in collaboration with many others to increase energy efficiency. Let's see if we can get it up here. There we go. In particular, I'd like to focus on our electricity usage. We use electricity, as we heard earlier, for a variety of things. And here you're just seeing a montage of things ranging from lighting, HVAC, the IT equipment we have in our homes and factories. A whole variety of things use the majority of the energy we produce out of that 97 quads. And we've made tremendous progress in improving the efficiency of these individual devices and the pieces of equipment that we use when they're running. The next challenge is, can we infuse them with some of that intelligence we just heard about, some of the things that we're doing here, so that not only more efficient when they run, but they know when to run. And that perhaps also they communicate with the smart grid to avoid peak load times. And that's what we're doing at the laboratory. And the invention that we're coming up with here, very simple, but it's something that we're calling Voltron. If we can get that up here, there it is. Device smaller than a deck of cards. And it's an innovation that we've come up with, really combining some of the technologies we already have today for controlling appliances and technologies, being able to do that from a building to campus to regional scale, and infusing it with some intelligence. So what is this device? It is a combination of the algorithms we just heard about, the real smarts, running on a very lightweight computing platform such as Raspberry Pi, and made available through open source. So our partners can download it from the Voltron.org website and use it in a variety of different applications. In fact, one of the things we're eager to do is partner with different people to explore the ways in which Voltron can be used. And we run an annual competition in partnership with DOE to do this. We're also partnering with people to adopt this technology. What can it do for us? Hopefully I can move a slide forward. What we have here is you can use that technology to within your building to control appliances or devices. Here we're just showing an HVAC unit and a refrigerated display case you might see in your supermarket. And you can control that device, a series of devices within a building, the entire building itself, so you now have a smart building connected to the smart grid, entire campus or region. More than just that, you can also then have it talk to the grid in a two-way fashion through something we call Transactive Control, which really enables a concept called transactive energy, which really does make the power of the smart grid a reality. So this device helps us do that. What are some of the successes we've had so far with this device, which is only a couple years in its making? Well, let's look at that first example here. And what you can see is that in the case of the refrigerated display case, our colleagues at Oak Ridge National Laboratory, in partnership with Emerson, ran an experiment, and they showed that if you use this, you could actually save a tremendous amount of energy. So think about those refrigerated display cases. They have a defrost cycle. Presently, that defrost cycle just runs every so often. When it runs, it's very efficient, but it also runs a lot when it doesn't need to. Suppose you had environmental sensors that brought in the data stream to Voltron that told you when you needed to defrost it, so you didn't run that defrost cycle when you didn't need to. That's what Voltron allows you to do. You can control that. 75% reduction in energy usage. And if you were widely adopt that throughout the United States, save enough power for 200,000 homes. Another example that we did, Pacific Northwest National Laboratory, with a small company, Transformative Wave in Western Washington, is looked at retrofitting Voltron into an existing buildings control product line they have and using it for rooftop HVAC. They're demonstrated in a very simple experiment up to 50% energy savings on that device. And not buying a bunch of new HVAC equipment, a retrofit of that technology into a product they're already offering. This is the promise of this technology, where you're really infusing a lot of what we already have in terms of energy technology and IT to bring together to make these things really smart. Now, that's what you're doing, for example, just to control a single device or a piece of equipment. You can also do that throughout an entire building and make the building smart. Or you can look at what you can do in terms of a campus. And that's what we're doing at Pacific Northwest National Laboratory. Here, we've installed Voltron in 9 different buildings with a number of devices connected to it. And we actually manage this and look at the whole campus now and what we're doing to control our energy usage, optimize it, and actually make the laboratory itself a test bed for demonstrating the power of transactive control. Here's an example of the control room we use here, where we can monitor all the energy and water usage at the laboratory as part of our efforts for sustainable operations. We look at this experiment we have going on here. That's what we're doing at the laboratory. In addition to that, we also have partnerships going on with the University of Washington and Washington State University. They're using Voltron in different ways. For example, the University of Washington is looking at using it in terms of the incorporation of solar technologies into their campus. Washington State in terms of the incorporation of large-scale stationary storage, as we heard about earlier. And they're each doing an independent study. What we're now getting funding from, the Washington State Clean Energy Fund, is to bring that together into a single regional demonstration of the power of transactive energy, where we can collaboratively manage our loads in real time in response to signals we're getting from the grid. We're doing that in the Northwest. We've now been partnering with colleagues in Ohio at the University of Toledo and at Case Western University, where they're also looking at this with respect to the incorporation of renewables and stationary storage. And they're doing their own demonstration, and our plans in the future is to link that to demonstrate the power of transactive control at a larger scale. And right here in Washington, D.C., we've already deployed Voltron technologies to 8 schools and buildings, with plans to go up to over 150 within the next year. So here what you're seeing is taking a very simple idea, a lot of smarts in terms of the algorithms, infusing that and bringing it together, and then working with people to understand the different applications we could have for this technology, and making it available to our partners so they can integrate it into their existing product lines and new product lines. We've already demonstrated the ability to save a huge amount of electricity in doing so, reduce much of that 2/3 of wasted energy, and save consumers, building owners, a lot of money in the process. And so what we'd like to do here is invite you to join us, looking for different ways in which we can exploit the Voltron platform, how you can develop those applications for it, make use of it, or if you're a company with a product line, talk to us about how you can incorporate Voltron into those product lines so we can have an even bigger impact. It's an opportunity to really bring together the kind of environmental sensing that we're going to have in the future around our homes and buildings, and exploit that to save money, save energy, and make the future a better place. So thank you very much.